today I'm going to be speaking about a data-driven approach to understanding and maximizing the reach of public art on campus. What I'll describe today is joint work with my colleague Abiy Tasissa at Tufts University and my other colleague Dina Deitsch, who is the chief curator of the Tufts University Art Gallery. To give a brief overview of the flow of this talk, it's going to be divided into three parts. First, I'll speak about the collection, then the audience who is viewing the collection, and then the algorithm. So to begin with the collection, the Tufts University Art Gallery collection is a collection comprised of 2,039 works by 679 unique artists. And both the artists and the subject tell a story. So in this visualization, you see one dot corresponding to each of the 679 artists. Blue dots are artists who have names, and gray dots are artists whose names are unknown. And the size of the circle corresponds to the number of works that a certain artist has in the collection. This collection, being the property of a university, it's not encyclopedic in nature as, say, a public art gallery might be, but rather it's focused on telling institutional stories. So it's meant to capture the people, places, and times of the university. And then also, of course, it is comprised of significant contributions via gifts by university alumni and donor. So a university collection will typically show something like this. So this is a very typical kind of piece in the collection. It's called Dr. Morton Henry Prince, and it's by the American artist John Singer Sargent. So Dr. Prince was the chairman of the departments of psychology and neurology in the late 1800s. And here, this is a portrait drawn by John Singer Sargent, who is a white American artist born in Europe, but an American citizen. And this kind of portraiture of white American men by white American men are very common. And this is kind of a consequence of the fact that many American universities are kind of steeped in this white American man legacy. Another important piece that you'll find in the Tufts University Gallery collection is this screen print called Kimiko Powers by Andy Warhol from 1972. And what you see here on the left is a print of Kimiko Powers, who was a friend and patron of Andy Warhol. And Kimiko was a Japanese-American woman. And what you can see is that there's a very traditional Japanese styling of Kimiko herself, being Japanese-American, but it's really heavily influenced by, of course, Warhol's very familiar pop art style. So you see these two things in communication with each other, both the cultural heritage of the subject herself and then the cultural situation of the artist himself. Here we have a work that is in a very different space. So the prior two works we saw were really descriptive in their elements, showing pictures of people who were meant to be identifiable. And this one is situated more in the poetic realm. The piece is called 5 Mauve Heads, 2 Yellow Heads, and it's by Mary Tillman Smith, painted in 1989. So Smith was an African-American artist from southern Mississippi. She was born to sharecroppers in the late 1900s. And her work is typified by vibrant but very limited color palettes. And she did most of her artwork in and around her property in Hazelhurst, Mississippi. So this artwork also tells a story about the art itself and the story of the artist. And here we're communicating the story of an African-American woman, and her art communicates a lot of her deep connection with religion. So those are three different ways I've shown now that artist and art can communicate with each other. If we look at the Tufts University Art Gallery collection and focus just on portraits, we can have a look at the gender identity of both the artist and subjects. There are just over 200 portraits in the collection, and what we can see is that the artists and subjects are largely male, with a handful of females, and we don't see any representation by transgender or non-binary groups. This can be a consequence of both the non-existence of these groups in the collection, but it could also be kind of a relic of poor data collection practices. A lot of the information that we have about artists in the collection was added either without the artist's consent or posthumously, and fails to capture the true dynamic gender identities that are present in the artist and subject. Similarly, if we look at the artist and subject race, we see that overwhelmingly both artists and subjects are white, with just a tiny smattering of other races present. So this collection is incredibly homogeneous in terms of race. So next, let's consider the audience who we have looking at these pieces. So this is a university collection, which means that it is shown in and around the university, both in the galleries of the university, but also across the public spaces on campus. So if we look at the people who are on campus, we can break these down into undergraduates, staff, faculty, and trustees. And if we look by gender identity, we have a reasonably good split between male and female, and even some representation by transgender and non-binary individuals at the undergraduate level. And again, the lack of representation for transgender and non-binary groups is likely due to poor data collection practices, not the actual non-existence of these people in the staff, faculty, and trustees. And if we look at the proportion of groups by race, we see that the proportion skews white, to be certain, but there is a significant group of non-white people at every level. So what we can notice is that the distribution of races at the undergraduate, staff, faculty, and trustee level, while predominantly white, is definitely not reflected in the Tufts University Gallery collection. So if the collection is meant to be a historical representation of the university, it is definitely not a current reflection of the university. So an interesting thing about university collections is that they can be shown anywhere around the campus. So it's the case that any building on campus, any department and so forth, can take out pieces on loan. For example, the Tisch Library, which is the main library on campus, has dozens of works hanging in it. And the President's House also has a lot of very important works. And in fact, there are 23 different buildings on campus that currently display 162 different artworks. So a question that comes up is, can we hang art so that everyone sees their identity reflected, whether in the identity of the artist or the subject of the work? This, of course, calls to mind some work done by Thomas Schelling on his models of segregation. So Schelling's model of segregation is an agent-based model that demonstrates how people's preferences for one another can lead to segregation or can lead to better integration. What Schelling showed was that even mild in-group preferences would lead to segregation. So this is shown really beautifully in a playable blog post called Parable of the Polygons that was written by Nikki Case and Vi Hart a few years ago. And what this demonstrates is that people, or shapes in this case, that have a preference for shapes or people who are different from them tend to have more integrated neighborhoods. So in terms of hanging art, what this means is, well, previously I said we wanted to hang art so that all people saw their identities reflected, but this is kind of a counterpoint to that, saying that we really want to hang art so that everyone is guaranteed to see something a little bit different from them. So what we want to do right now is find a way to hang art around campus that both prioritizes exposure to artists with backgrounds different from the viewer, like in Schelling's model, but also guarantees that viewers, especially from minority groups, see their own identities represented. So what we need to do is find some kind of a optimization scheme that can simultaneously prioritize these two things that are seemingly at odds with one another. So what we've devised is an algorithm that can solve these two kind of constrained problems in one go. So what we propose is the following. We define the set of all available art, A, as A1 through AM. So this is the set of all artworks, of which we have 2,039. And then the set of all buildings where art is displayed, so B1 through BN. So in our case, we have 23 different buildings. And our hope is going to be to somehow map the artworks onto the buildings so we learn exactly where each piece should be hanging to satisfy our motivating questions. So the way that we set this up is by defining a cost matrix. So there's a cost to hanging an artwork in a building. I denote that cost by a lowercase c. So the cost of hanging artwork AI in building BJ is informed by both the composition of the building and the characteristics of the artwork itself. So if we look at the characteristics of the artwork AI, the artwork can be thought of as a vector with component values little a1 through little at, where each of these little aj's is some kind of categorical component of the artwork. So this might be something about the artist race, gender, cultural identity, or maybe the subject race, gender, or cultural identity. And the composition of the buildings can be determined similarly, except now the components of the building vector are some kind of weighted average of the components of the people inside the building. And we can do this by looking at the buildings on campus where art is hung. We can do a little bit of web scraping to see which departments and administrative bodies reside in the buildings. And we kind of have an idea of who the people are who walk through each department and administrative body. So using these vectors, we can basically make up a cost matrix. It's an M by N cost matrix where the mnth entry is the cost of hanging artwork A in building N. So using this cost matrix, what we do is we run an optimization program to learn an optimal assignment matrix, which we call capital P. So capital P is found by minimizing over the trace of C transpose times P. And P here is an N by M matrix where the entry in row N and column M is the probability of assigning to building N artwork M. And we have a few additional constraints here. First, H, little h, is an N by 1 vector of building capacities, because of course we know that one building can have many, many pieces of art in it. And P prime is the sum over all rows of P. So in this way, we have a kind of constrained optimization problem where after gradient descent, we determine an optimal capital P, where the entries of P give us some kind of probabilistic weight for how likely it is that we should hang a certain work in a certain building. So we're still working on finalizing this model and parameter tuning to come up with the best possible P, but the goal or the eventual outcome will be that we have a matrix P where we have values between 0 and 1 in every entry, and values very close to 1 mean that it's very, very good to hang a certain artwork in a certain building. And just from our preliminary testing, we found that certain artworks in the collection are favored by many buildings. And one that was particularly well liked was this one artwork called Bon Voyage No. 1 by Asuka Osawa, who's actually a graduate of the Tufts School at the Museum of Fine Arts. And this was one work that it's by a Japanese-American artist. And you can see the kind of cultural influences of the print itself. And this had very, very high likelihood for a lot of the buildings on campus. So we'll continue to refine our models and hopefully come up with some interesting assignments and maybe operationalize that on the campus and beyond. Thank you so much.